Now that we've gone over relations, there are certain types of relations that are known as functions, and we need to be able to identify which relations are functions and which relations are not functions. So, we need to define what a function is. First off, a function is a special type of a relationship. This relation assigns one member of the domain exactly to one member of the range. So a special relationship that assigns each member of the domain exactly to one member of the range. An easy way of remembering this: x's cannot repeat. If a number in the domain is assigned to another number, it can't be assigned to a separate number. If 3 is in the domain, it can't be assigned to 2 and 4. We're going to go over some examples of this. So the domain, exactly one member of the domain has to be assigned to one member of the range. So let's look at some examples. This first one is an example of something that is a function. So what you do is you look at the domain. 2 is assigned to 4, 3 is assigned to -6, -7 is assigned to 8, and 10 is assigned to 11. Everything's fine. This is an example of something that's not a function. On this one, 2 is assigned to 5, 4 is assigned to 3, but then they're trying to take 2 and assign it also to 7. 2's already assigned to 5. This number right here, 2, which is in the domain, can only be assigned to one number. So let's look at some other examples. Which of the following is a function? So this one's listed as a table. 9 is assigned to 4, 14 is assigned to 7, and 16 is assigned to 12. Then yes, that one is a function. However, looking at this table, they're trying to take 16 and assign it to 19, and they're trying to take 16 and assign it to 2. If the x's repeat, like it's doing right here, then it's not a function. So this one, yes, this is a function. This one, no, it is not a function. Let's look at an example when it's the mapping. The domain right here is 0, 1, and 2. What they're trying to do is they're trying to take this 0, and look, there's 2 arrows coming out of it. They're taking that 0 and trying to assign it to the 4 and the 5. That means this is not a function. When you're looking at a mapping, there should be one arrow coming out of each one of these numbers in the domain, like this one. There's only one arrow from that one arrow from that one. Wait a minute, I've got 2 arrows coming from this one right here. I've got this one trying to be assigned to -4 and the one trying to be assigned to the 0. So this one is not a function. For it to be a function, I only need one arrow coming out of each one of the domain when it's listed as a mapping. We've got a series of points here. We need to look at these points and see whether or not they are or not a function. So what I do is I look at the x's, and I look and see if any of these x's are repeating. And look, I do have one that's repeating. This 4 right here is repeating. That means this right here is not a function. Looking at this one, I've got a 3, a 4, a -5, and a 10. The only thing I have to look at is the x. It doesn't matter if the y is repeating. The only one that matters is the x cannot repeat. I can't assign an x to a different number. 3 is assigned to 0. 4 is assigned to 0. It doesn't matter if the y's repeat. It only matters if the x's repeat. You should be able to look at a graph and tell whether or not it is or is not a function. Again, you're only worried about the x values. The x value right here is -4. X value right here is -1. X value right here is 3. The x value right here is 4. And the x value right here is 5. That means this is a function. As soon as you see a point where they're on top of each other like this, that means they're sharing an x value. that means now it's not a function. So if you see two points on top of each other like this, when it's a graph, it's not a function. And in the next video, we're going to go over what's called a vertical line test, where you can look at graphs and tell whether or not it is or is not a function.